Our next method to demonstrate how to solve a system of equations is the method of substitution. All right, so to make this work, you must have one variable that is isolated. So you're going to get two equations. We need one variable to be solved for. Okay, once that happens, we're going to substitute that equation into the other equation. And that combines them into a single equation, and one of the variables will be gone at that point. I'll show you how that looks. Okay, we're going to solve that equation and get that one variable value. Then we solve for the other variable using the value we got from step 2. All right, so I know there's a lot in there, so just kind of watch the process. All right, so to start off with, remember number 1, you have to have one variable that is isolated to make this work in substitution method. All right, so example A. All right, take a look at the two equations. I have slope-intercept form in the first one, the other one is standard form. Well, the first one, this is solved for y, so y is isolated. All right, so that's the key here. So let's get in the habit. When you have a variable that is solved for, a good thing to do is to actually just circle it. That one's by itself, okay? Now, I want you to go to the other equation and find that same variable. Here it is. All right, so what we're going to do is get rid of the y here. We're going to substitute something in here to get rid of it. So we have to know what y is equal to. All right, so y is equal to 2x minus 4. That is what we're going to put in place of the y. All right, so y is solved for. We know what y is equal to. It's equal to 2x minus 4. So we're going to replace this second y with that quantity. And it looks like this. So that gives us a new equation. So the second equation becomes 7x minus 2. So all of that stays the same. But right where the y is, we're going to replace this y with the quantity it is equal to. So these two quantities are equal. I can replace one with the other. So 2x minus 4 goes here, equals 5. Now look at what we have after I did that. There is no more y left. That's the key, and that's what I meant up here. This produces an equation with only one variable, and that's what we have. We only have the variable x. So we've essentially gotten rid of the y. We're using a substitution. All right, so what we have to do once we get to that is to solve that equation. All right, so I'm going to start with, I've got some parentheses, so let me use the distributive property, -2, distribute that multiplication. So that gives us 7x minus 4x. -2 times -4 is positive 8, equals 5. And to solve this equation, I have 3 terms here on the left side, and 2 of them are like. So I'm going to combine those. 7x minus 4x is 3x. And then you just solve as you always do. Let's subtract 8 from both sides using our balancing and inverse operations. And undo the 3x by using division by 3. All right, so what that gives us is the value for x. All right, so solve for the other variable using the value from step 2. So the value from step 2 is x is equal to -1. So now we need to figure out what the y is, and we're going to use this equation up here to help us. So we can get y is equal to twice the value of x, subtract 4. Let's calculate that. So y is equal to twice the value of x, subtract 4. And so you substitute in now x equals -1. It's going inside here. So negative 1 right here. Let me write that in red so you can see that change, all right? So you can actually use either equation to do this. This one's so convenient though because it has y solved for, and that's what we're trying to figure out is what is the value of y when x is negative 1. All right, so let's do the math now. So y is equal to 2 times negative 1, negative 2. Subtract 4, and then combine those, y equals negative 6. All right, so when x is negative 1, y takes on a value of negative 6. So our solution is the ordered pair, x first, negative 1. The y coordinate is negative 6. So this represents the point where those two lines intersect each other. And so this is using algebra. This is an algebraic technique. Previously we graphed them and located that point, but graphing is not typically a very successful way to do it unless you're using computer. Because by hand, what if they intersect at a point which is not a lattice point? Then you start estimating and it's not exact. Algebra, we always get the exact answer. So negative 1, negative 6 is the solution. So let's practice this a few times, okay? All right, so take a look at the next system. We have both equations are solved for y. That's cool. All right, just like before, the one that we have solved for, let's circle it. So that's the first one. And the second one also. All right, so remember what we do. We're going to take, we know that y is equal to 2x plus 3, and y is equal to 5x. So that means I can take, well, I can use either one. What if I use the bottom one? So y is equal to 5x, right? So I can replace the y. I can take this 5x and replace it where the y is. Okay, so I'm going to substitute this 5x in where that y is because they are equal to each other. Okay, so I have 5x is equal to, so 5x goes here, and it's equal to 2x plus 3. And this should make sense. If y is equal to 2x plus 3 and y is equal to 5x, then these two should be equal to each other. All right, so that's essentially what we've done, and now we've got an equation with only the variable x, and we're ready to solve it. So I'm going to subtract 2x from both sides. It's 3x. And divide both sides by 3. X equals 1. Now we're going to need that variable, so we're going to do step 3 now. We're going to solve for the other variable, which is y, by replacing the number, the x equals 1 into one of these equations. And it really doesn't matter which one you use. Just to prove that point, I'm going to do it twice. Okay, so I'm going to use the equation y equals 2x plus 3. And I'm going to use the equation y equals 5x. Okay, so these aren't my answers. I know I'm boxing them, but I'm sort of putting them as titles. So I'm going to put x equals 1 into both of these. Okay, so if I put it into this one, I get y equals 2 times 1 plus 3, and that is equal to 5. If I put 1 in here, y is equal to 5 times 1, and that's just 5. So no matter what, I get the answer of 5 for the y. It doesn't matter which equation you choose to do that substitution into. So the final solution is the point. Remember, all solutions are ordered pairs. So it'll be the x value of 1 and the y value of 5. All right, the two lines intersect at that point. All right, let's try it again. Take a look at example C. Which equation has a variable isolated? All right, you should be looking at this one. We have the variable x all by itself, so I'm going to circle it. Then I go to the other equation. I don't have any isolated variables, but I do see the variable x, so I'm going to circle that too. This is where my substitution is going to occur. I'm going to get rid of this x and replace it with what it is equal to. What is x equal to? Right here. Okay, so this is going to go in here. Let's do it. So I have 2 times whatever x is equal to, so 2 times something plus 4y equals negative 1. So we're replacing this x now with this quantity, 5y plus 3. Notice the 2 that's multiplying the x is still 2 is still here with the quantity 5y plus 3 because that's the same thing as x. I still have plus 4y. I still have equals negative 1. So all of this equation, the second equation, is completely identical except for instead of x, I have this quantity. And now this is something that only has one variable, and so I'm going to solve for that variable. Let's distribute first. So 2 times 5y, 2 times 3, so plus 6, plus 4y equals negative 1. So let's simplify this. So we have 10y and 4y on the same side, collect like terms, that's 14y plus 6 equals negative 1. And then start solving. Okay, and then we're going to divide both sides by 14. All right, we get 1y equals, and divide the numerator and denominator by 7. That gives us negative 1 over 2. So negative 1/2 is the y coordinate. And now we need the x coordinate. So let's go back up here and plug that y value in. So we have x is equal to 5 times the y plus 3. All right, what the y value is negative 1/2, so substitute that in. All right, so 5 times 1/2, okay, so that's x equals negative 1/2 of 5 is 2.5 plus 3, and add those two together. We get x is equal to positive 1/2, 0.5, or keeping it in fraction form, 1/2. All right, so put it together. Our solution is x coordinate first, then the y coordinate. All right, so what happens, take a look at example D. What happens if we haven't got a variable isolated? That means you got to do a little work. So we can solve for a variable. It's not that big of a deal. So for instance, what if I take this first equation and I solve for y? Let's get y by itself. Well, what would I need to do? I would need to subtract x from the left side, and I need to subtract x from the right side. And I get a new equation. So x minus x, that's 0, leaving y. Y equals 50 minus x. Let's rewrite the second equation. All right, oh, actually I don't need to do that. So I've got my variable isolated, right, which is y. I need to go find that variable in the other equation, right here. So this is where I'm going to do my substitutions. Let's rewrite this equation. 2x plus 1.5, but instead of y, we write the parentheses, equals 90. So it looks identical, but we take the y out and we replace it with what it's equal to, which is 50 minus x. That's what goes in here. And then we solve for x. 1.5 times 50, whoops. That's 75. And then 1.5 times negative x, that's negative 1.5x. All right, so distributing. The multiplication. and then bring down the right side, equals 90. All right, like terms, we have 2x and we're subtracting 1.5x, so let's combine those. So 2 minus 1.5 is 0.5x. And we have plus 75 equals 90. And start solving. So subtract 75. And then divide both sides by 0.5. And that gives us 30. All right, and then again, we need to know the other value, so we're going to plug it back in. When we have two variables, we should get two coordinates solutions. So we're going to plug this back in. Y is equal to 50 minus x, so let's write that. Y equals 50 minus x, so substitute this 30 in for the x, so y is equal to 50 minus 30, which is 20, and put it together as an ordered pair. 30, the x goes first, the y value goes second. That is our solution. All right, it's time for you to do some independent practice.